Okay, let's see if we can't solve this problem here. Water is flowing at the rate of 50 cubic meters per minute from a concrete conical reservoir, vortex down of base radius 45 and height 6 meters. So this thing has a really big base and not that big of a height. And so let's write that in here. So we know that this distance, the base radius, so from here to there is 45, and the height from here to here is 6. So I know it's not the scale, but you know, it is what it is. How fast is the water level falling when the water is 5 feet deep? So here's the water level. Sorry. Let's try again. Here's the water level in the thing. So the water, I want to know when it's 5 feet deep, how fast is it coming out of the bottom of the cone? Because it says it's flowing at the rate from a conical reservoir vertex down. So that's where it's coming out of. So what do I seek? Well, I'm seeking this water level. Is that right? I mean, how fast is the water level falling? So let's call this level here our level H. So I'm looking for dH to dt. And what do I know? You can see the formula for the volume of a cone right here. But what I know is that it's flowing at a rate of 50 cubic meters per minute. So I know the volume, dV to dt, is negative 50. It's negative because it's reducing. So how fast is the water level falling when the water is 5 feet deep? And then how fast is the radius of the water's surface changing at that moment? So we're going to do A first, because if it's laid out this way, I'm pretty sure that our answer to B is going to rely on our answer to A, or at least it's going to make it a lot easier. So what else do I know? I know that that the ratio of height to radius is 6 to 45. So height to radius is 6 to 45. And I know the equation for volume is, I'm going to write it over here again. So I know that volume equals 1/3 pi r squared h. So I'm going to call that pi over 3 r squared h. And I can see immediately that I have a problem, because I am seeking dA dt, and I know dV dt, but I have this r in there. And that's going to cause me a problem, because I'm doing single variable calculus, and that would be multivariable calculus. So what I'm going to do is, with my knowledge here that the ratio of h to r is 6 to 45, and I'm seeking dH dt, I'm going to change my r to be in terms of h. So I would get 6r equals 45h by cross multiplying there. And that means that r is equal to 45 over 6h, which I can simplify to 15 over 2h. So now I've got r in terms of h, and I can change my volume formula so that it just has a single variable on the right. So I have volume is equal to pi over 3, 15 halves h squared h. And that's what it is. Now I have Yeah, pi over 315 has to, yeah, I have that good. So I'm going to kind of make this into a more manageable equation here. I have volume is equal to pi over 3 times 225, that's 15 squared, h squared over 4 times h. So I can see that P goes into 225, so volume is equal to, 3 goes into 25 75 times, so I have pi times 75 h squared over 4 times h. So let's make it even a little bit easier to work with. I'm going to go, I'm going to call this volume is equal to 75 pi over 4 h cubed. So I took 75 over 4 and I put it in I combined it with the pi, so I have a nice constant right there, and then I took my h squared times my h and I get h cubed. So now, if I'm seeking dH dt. I know dV dt, so I'll take the derivative of both sides, derivative with respect to t of both sides, and I get dV to dt is equal to, well, I'll pull my constant through the derivative, so 75 pi over 4 d to dt h cubed. So I have dV to dt equals 75 pi over 4, and this would be 3h squared dh dt, using the chain rule because I know that h is also a function of time. So dV to dt is equal to, 3 times 75 is 225 pi over 4 h squared dh dt. Oh, come on, here we go. So I need my, I'm going to change my dV dt to 9, because I know, no, it's not 9. It's negative 50. dV dt is negative 50. So negative 50 is equal to 225 pi over 4 h squared dh dt. Man, I'm trying to get dH dt all by itself. So I think I'll start by multiplying both sides by 4 over 225 pi. So I'm going to multiply this by 4 over 225 pi. So I'm kind of canceling out this right here. So now I have negative 200 over 225 pi is equal to squared dH dt. And so now how about if I just multiply both sides by 1 over h squared, which is the same as dividing by h squared, times 1 over h squared. So now I have negative 200 divided by 225 pi h squared is equal to dH dt. So I've got dH dt all by itself. This is the formula for finding dH dt, and the problem is saying, what is it when the water is 5 meters deep? So Now I can substitute in for my h, because that's a changing number. That's my 5. So I have negative 200 divided by 225 pi times 5 squared would be 25 is equal to dH to dt. So I could simplify that just a little bit more, actually, because 25, well, come on now. 25 goes into 200 8 times, so I'd have negative 8 over 225 pi equals dH dt. And that would be a perfectly satisfactory answer in meters. Meters per minute? Yeah, meters per minute. Meters per minute. The question asks for centimeters per minute, which just means I just have to multiply it by 100. So that would be negative 800 over 225 pi centimeters per minute equals dH dt. See, I can probably make that a more simple too, because I can divide the top and the bottom by 25, and so 8 divided by 25 is that's negative 32, and 225 divided by 25 is 9 pi centimeters per minute equals dH to dt. So that is the answer to part A. Part B says, how fast is the radius of the water surface changing at that same moment? So the radius of the water surface is this right here. It's not the 45. It's this right here. It's where the water surface is. So I guess I could go through the whole thing again using volume but changing it over to radius. But there's a much simpler way to do that, and that is, I know that I'm going to make sure I get that 6R equals 45H. So I know, going to the bottom here, that 6R is equal to 45H. And I am seeking now dr dt. Well, so that means that R is equal to 45 over 6H, which we've already simplified. R is equal to 15 over 2H. And now I'm just going to take the derivative of both sides with respect to time. So I'm looking for something to make my problem a little bit easier, which this does. I'm going to take my 15 halves and pull it through the derivative. So I have dr dt, which is what I am seeking, is equal to 15 halves d8 dt. Well, guess what? I just found dH dt right here. It's negative 32 over 9 pi. So this goes to be equals 15 halves times negative 32 over 9 pi. That's dr to dt. So I can simplify this a little bit. The 2 can go into the 32, that would be negative 16. I can go 3 into the 9, that's a 3, and that's a 5. Is that right? Yeah. So I have negative 80 over 3 pi centimeters per minute is equal to dr dt.